Run the recording. So for those of you who are just coming in, so Runestone, yes, my Runestone. If you've got a bunch of Runestone 0 grades, that's my fault. Where you should have had it. So here's what happens when I do my grading. This is where I go. I go to instructor dashboard, and then I go over to the grader. Okay, and when I go into the grader, I basically select the assignment, and then I basically go through these one by one, and I hit run scores, questions, and update total. Now, last night, I decided to do that again, and then today I ran the script to import everything. But here's what happened. I forgot to uncheck this box, which is checked by default, which says see or check work submitted before, and then it's the due date of each individual assignment. It changes based off of the assignment. So that only grades the work that's been turned. So what that apparently does when stuff has already been graded is that it says, well, I'm going to grade stuff that was turned in on time, but if it wasn't turned in on time, it's a 0. So all your grades got switched to a 0 if you didn't do it on time, as they should not have been. Now this is completely fixable and has been fixed for a few assignments, because all I have to do now is just simply select the appropriate assignment and hit score questions and totals, and then it will then proceed to rerun the grader for all this. I have to just do this again tonight and then rerun the import script again. A pain, but so this is a pain. It was a mistake. It's a fixable mistake. No action is required on your part. Again, as long as things are done, and if you still have to work on some of them, as long as stuff is done by December 8th, I'm going to be happy to consider that, okay? Next, with regards to Exam 2, please email me. So you should be getting your Exam 2 back. If you have questions about it, email me with me over Zoom, and I still have to grade the ones from DRS. Completely forgot about doing that. But email me. I will grade those things. Email me. I will be happy to take a look at your grades, and I'll be happy to see. Okay, were you graded a bit too harshly? Were you, did the TAs, were they not able to read what you wrote? Which is actually an issue that happens sometimes. So if you feel like that you were treated a bit more harshly than you should have, just email me. I'll be happy to take a look, okay? Now, so that's with regard to Exam 2. So please just reach out. I'll be available over Zoom the entire break as well as this week. So please, because the median score apparently was like a 50 or something. It's ridiculously low, I feel like, this semester. And again, we drop an exam, so I don't necessarily think I have to adjust anything there. But we will see. If worst case scenario, I'll move I'll recategorize and rescore some of the extra credit I'm deploying, like the PIG assignment that we're going to go over today. I'm going to go over the PIG assignment. Right now, that's as extra credit for assignment. If need be, I'll lower the amount of points it's worth and move it over to like exams for extra credit. But here's the thing: PIG, it has 8 parts. I'm going to go over the first 4, possibly 5. This means if PIG is worth 50 points or 30, let's go with 30 points of extra credit, and you turn in the 4 parts that I do, that means you should be, which is half of it, you should be getting how many points of extra credit? 15. And I go over this even when I do this as a normal assignment, which means that so this is a freebie, so this means everybody should turn it in, right? Is everybody going to turn it in? No, they aren't, because it's a mess. All right, because everybody here is going to turn it in because you're here. You're showing up. You're doing the job. It's everybody else that doesn't show up that I've got to worry about. Okay, so with regards to that kind of stuff, we will, I'll go over that in a bit. But I also sent out an email last night. I sent out the practice exam 3 because I wanted to make sure you had plenty of time to go over it. Students were asking me what's going to be on exam 3. I want to know. I'd like to know too, so I figured I'd better work on that problem, and I did last night. So I figured out, okay, this is what I've got on here, and then here. Let's just take a quick look at this. Okay. Just a very quick look at this. Download this because it renders better like this. So I could not figure out how to rescore, like where to remove a question or rescore it. So this is inaccurate, 115 points. I mean, again, this is accurate for the practice exam. The actual exam will have 105 like usual. Okay. This should be inverse of lowercase d. I fixed that on the actual exam, not on the practice exam. But you'll see that I do have quite the extensive notes on the back here for regular expressions. So there's going to be a lot of questions on the exam along the lines of this. Specifically, 35 points worth of these questions. Not 35 questions, okay? Most of the questions will be like 5 or 7. I think on the exam I have like I have like 5 questions each worth 7 points or something like that look like this. Where here, which of the following strings do the given regex match? And so basically you bubble in the ones that this matches. Okay, I'm not going to go over this now because I want you to get the chance to practice on your own. What I will say is that while these are bubble-in questions, treat them like true-false questions for grading purposes. Meaning that if there were that basically you would be given credit or marked incorrect based off of each bubble, whether it should be bubbled or unbubbled, right? So you get credit. So technically, if you left it all blank, you'd probably still get some points on that one, just because of the way the grading scheme for this one works.
Is it like if you choose a right answer, you get a point. If you choose a wrong answer, you lose a point?
No. It's you get a point for either filling it in correctly or leaving it unfilled correctly.
What do you mean unfilled correctly?
You don't. If it doesn't match, you don't fill it. Just it's.
Oh, okay.
Yep.
What do you mean filling it in incorrect? If I fill one in.
If you fill one incorrectly, you don't get credit for it. No, you're overthinking it.
Or you don't get penalized for choosing the wrong answer.
No. I'm not over. You're not losing points for guessing incorrectly.
But you also gain points if you bubble and correct, right?
That's the way everything works. Yes. So we have a lot of questions where we have the regular expression, and you comment out and I give you this over here, and then I give you a question like along the lines of, you should expect a question like this. Okay, for the above regular expression, how would you change it to do something, right? That's definitely on the exam. Okay, for above so here, right, we have this over here. And here I'm saying, please change it so you would match only these things. And then here, right, I had the given a regular expression match, tell me what strings match. Yeah. And let's see. And then I will have the opposite question, which is, here's strings, which of the following regular expressions match all those strings, right? So the reverse. Or if I have a string, or it might be one. So the point being is that basically there's a lot of these bubble-in questions, and they worked out. I will point out though that these two are actually from last year's exam. This one is an example of what we would see on the exam. Select all the strings that match this regular expression, and then this one, here's Batman, Superman, Superwoman, and Batwoman. Please select all the regular expressions that match those, right? Which one of those? So for instance, this one would be bubbled in because it will match all of those, and it can match more than just what's listed, right? I will say that basically that the question on the actual exam, then we have a 20-point file reading question. Not file reading, regular expression question. I went over this on last Thursday. where given a file, replace all the contents of the file, but remove some personal information. Here, that personal information is phone numbers, right? Phone numbers in the US look like this, but I'm saying match these patterns, but not necessarily this pattern. The reason I put that in is I don't want a smart aleck who basically says, I'm replacing the entire file with private. There's just, I'm deleting everything. All the information's removed, right? No, I only want you to remove the relevant information. All right? So basically, by the way, it's very interesting to have to write down the description for a US telephone number as though you have to explain it as though somebody has never seen one before. Okay? But it is, open parentheses, area code, close parentheses, space, 3 digits followed by a dash. This is very, 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 I will tell you straight up, this is very, very similar to what you're going to have to do on the exam. If you can do this, you can definitely do the one on, if you can just do this by hand without having to look anything up, you're going to be great for the exam. Okay, easy. Just review what we did. Okay, but here's the exact same rubric that you'll see on the exam, only with, instead of phone numbers, it's whatever the number is going to be on the exam. Okay, 2 points for reading the file correctly, 12 points for doing the regex correctly, 2 points for successfully writing the new file, and then 4 points for remembering how to do that whole substitution thing. I link you to additional regular expression practice. It's called regex golf, which is basically trying to match all of these things, but none of these things in as few strokes as possible. A stroke being basically keystrokes. Okay? So those are some good regular expression practices. Other ones, regex 1. So these are just good generalized regular expression practice in general. Okay? So I then have 2 questions that are function questions like we had on the exam 2. There's really only space for me to give you 1 or 2 of those questions because we're doing it in here. We're only going to have 70-ish minutes, right? So I'm going to be doing the exam. I'm going to be crafting the exam to that time limit. And who knows, I might get lazy and decide, oh, a lot of people got this question on the exam wrong. I probably will do something very, very, very like this question from exam 2. Because I am very lazy, but I'm also an effective teacher. So doing these kind of things, these kind of problems will be only 2 of them on the exam. Then you'll have 20 points for Monte Carlo, 20 points for file reading. So first, let's go over the file reading question. Notice that I put down hard. I gave you a deliberately hard file reading question. I think the the exam question from sorry, let me go ahead and do this, and then I'll give you another question like right here. Okay, kind of over here. That might be a good match. So here, this is a very numerical heavy one, which basically says, hey, return the sum of all the numbers in the file that are adjacent to its square root. For instance, this will yield 73 because in this line, 25 is next to 5, 4 is next to 2. So 25 plus 4, 36 is next to 6. All the ones are adjacent to each other. So this one's tough because of all the things, because you have to read it and then you have to do the square root calculation. Or specifically, here's my rubric, which also doubles as your step-by-step instructions for this tough problem. Reading over the file, iterating over line, converting, that should be the line, into a list of integers, doing a running sum, identifying which numbers are adjacent to their square root, ensuring no out of bounds, returning the sum. Also, note that I give you this function right over here, lines to int, magic function that turns a string into a list of ints. Okay? And I just added this last night. You should use this because on exams I've sometimes given like magic functions that help students out, and then the students proceed to ignore them. even though that's like, this this takes a line and converts it to a string. Converts it from a string into a list of numbers. It does exactly what you want to, and all you have to do is call it, right? That's literally does 2 points for you if you call it. Okay? So when I give you this kind of thing, use it. And let me just briefly explain. What it does, the key here is something called map, which is a very powerful function built into Python. And you'll notice it takes in int as an argument. It takes in a function as an argument. That's kind of weird. But you can do weird things in Python, and that's what I love about it. You can do things that actually... Here, let's go ahead and just briefly show you what I mean. So, desktop, I'm going to call it weird.py for 1 second. Def, add, A, B, return A plus B, right? Doesn't really get any simpler than this. It's just returning 2 numbers, right? Print, add, 1 plus 2. That's going to give me 3 back, right? Great. Okay, what if I just simply printed add, right? Not the function call. It gives me function add at this memory load address. You can do stuff with your functions. There's nothing stopping you from doing this monstrosity. F is equal to add. Print F. What is F? Oh, it's the function add. Which then you can say f of a comma b, or sorry, 1 comma 2 is 3. Functions are just variables. Your verbs can be treated as nouns. You can turn them into gerunds if you would, if you will. You can treat your verbs as your noun. We're making these verbs, but we can treat them as nouns, which is kind of crazy. Map, what map does is weird, is that it applies a function to something, to some output. And here it's basically saying, hey, split this, take this line, split it up. We've got this collection of this list of numbers now, this list of strings now, apply ints to each of them, and now just turn that output into a list. So anyway. So this one, again, is much harder than the question I would give you on the exam. A question that would be more similar to what I would give you on the exam. Okay, so reward for you for coming to class and actually, or following up on this lecture. Suppose I'm taking we've got a Mario Kart, I've got the results for Mario Kart, okay? And the file looks something like this. Okay? The file looks something like this. Player, right? Player, comma, lap 1, lap 2, lap 3, total time. Right? And so maybe it's Mario, 30, so maybe it's Mario 31, and then maybe he gets hit by blue shell and 40, and then whatever the sum of this is, which is 103, right? Now, if I give you a file, of course, because I'm not sadistic, you're not actually going to have this first bit, right? It's just you're not going to have to worry about this dealing with that legend, right? I'm just putting it there as kind of a fake for you. So, and then you might have Peach, and she did 40, 32, right? And that gives you 112, right? And so on and so forth. So a question I might ask is, who won? E.g., who got the lowest time, right? The lowest total time, and who had, and then another question might be at the same time that I might ask is, who had the best average lap time, right? So you'd have to figure, so that's two things you're going to figure out as you're iterating through. Who had the lowest total and who had the best average. So in other words, if you add all these up, then divide by 3. So that's probably closer to what I would, still harder I would say, but closer conceptually to what I'd be doing on the exam. It does involve a race. So there you go. That's part of the reason why. Okay. Monte Carlo, 20 points. Okay. So Monte Carlo is a problem that's similar to one I went over in class, but a bit different. Suppose Professor Rosen wants to play a game. You win, you get $1. You lose, you pay $1. Game works like this. 7 black cards, 2 red cards. Okay? And you arrange them randomly in a 3x3 grid. You play the, okay, so we create a 3x3 grid of cards. So this is definitely harder than what's going to be on the exam. Okay? You can play, you play by flipping over 3 cards in a line. It can be a row, a column, or diagonal. So you flip over 3 cards in a row. For statistical purposes, remember, you're just doing one thing and doing it the same thing over and over again is this, works. If you can flip over 3 black cards in a row without flipping over any red cards, you win, right? And I mean, come on, there's only 2 red cards. How hard could it be? So, print your code on the next page. Here's the rubric for that. Yeah, is it just me, or is this an indication the actual exam might have a card scam as the question? Yes, you will have another card scam as your question on the exam. On the exam, though, you'll be dealing with an actual deck of cards, so for which I will provide you a string already set up as the deck, so you don't have to write 2, 3, 4, 5, 6, Jack, King, Queen. Okay, so you don't have to write that out. For that one, and I will say for that one, just you will probably want to be able to split that deck just randomly into piles. That's the most I'll tell you about that. Okay? Okay, so if we go over this, then you have 20 points here for Monte Carlo, 20 points here for file reading, so that's 40 points so far. Then I'd say, then you have another 20 points for the regular expression, so that's 60 points right there in 3 questions. But this one is fair, but again, they have very well-defined rubrics that make it easy to get partial credit if you follow the directions. Then I'd say the remaining 20 points, then of the remaining 40 points, 20 would probably be regular expression and 20 would be, those function questions like you had on exam 2. Give or take 5 points either way. Right? So yeah, so it's, again, I'm aiming for a shorter exam. Okay? Again, this should be a very good guide for you to do this kind of thing. So the plan is on Tuesday, once we get back, our first lecture, as soon as, our second to last lecture, what we're going to be doing is we are going to be doing this practice exam. I'll be going over it and solving all the problems. If, however, that does not mean you cannot ask me how to solve these questions like over the break as if you decide to work on it. I will completely understand if some of you who have been keeping up to date decide, you know what, I ain't doing anything. I totally get that. That's totally how I operated during the break, or during breaks when I was a student. It would often be like, oh, right, I guess I have to do stuff Saturday night now, or I really should spend some time catching up, but sometimes you do need to give yourself a breather. Okay, so once again, for the people who joined late, I forgot to uncheck this box, which is why you have a bunch of zeros when you shouldn't have zeros. So now I'm rescoring this. And I will just have to go through all of them tonight. Again, it's fine. It's my bad. I'm human, I make mistakes too. All right, let's talk about Pig. So this is our extra credit, this is an extra credit assignment. Again, there's 8 parts to it, you'll need to do 4. These build progressively towards a larger result while working on Monte Carlo methods. While we're doing this, I will of course be teaching you new concepts that will not be required for the exam. They're just cool pieces of Python, I think, that are very cool. Okay? So again, how does Pig work? So Pig is a game of chicken, because I just love making that comparison with animals because it's ridiculous. Pig is a game where you are aiming to get a 100 point by rolling a die. During your turn, you can roll a die. It's a single 6-sided die. If it lands on the numbers 2 to 6, you increase your score for that turn by that much. If you land a 1, you lose all. Your turn ends. You don't get any points that turn. Lose anything that you've made that turn, and it goes to the next person. Right? So basically, you keep rolling until you hit a 1, or you decide, stop, I'm not rolling anymore, in which case I save all the points I made for the turn. The reason you save those points is because once you've saved those points, once you've ended your turn by your own decision, those points are safe, you can't lose them, right? Otherwise, if you could lose those points, there'd be no reason to not just keep rolling to try to win, right? So we'll be asking questions about optimal strategies and whatnot as we're kind of coding this up, okay? As we're coding this up, it will be, as we are coding this, no, I don't need submissions, sorry. As we are coding this, we will be asking questions about, statistics and Monte Carlo and seeing as we do things. So we're going to start by basically just having the computer do a turn, okay? We're going to simulate a computer playing a turn of this game. Now the computer needs to have a strategy, and the strategy that we will be using for the computer, and I need to emphasize this from the very beginning, the computer follows this strategy. Humans can be dumb. They can do whatever the hell they want. The computer will be following a strategy of, once I get at least 20 points, I'm done for the turn. Humans don't have to stop when they get to 20. This is a common mistake I see people program, where they think human has to stop. Maybe it's an AI thing, I don't know. But a human basically they play until they say stop. Computers will play until they get 20 points or however many they define. All right. So the 8-part, each part looks like this, where I give a sample description, and then I give you a description of what's going to go on, and then I give you an output. So here, this is the output of different rolls. For instance, we run the program, and we see that the computer rolls until they get 20, or they roll a 1. Here, the computer rolled. They scored 21 for the turn because it had 5 points. It said it's not 20 yet. I have 7 points. That's not 20 yet. I have 10 points. That's not 20 yet. I have 16 points. That's not 20 yet. I have 5 points. 5, that's 20. Sorry, I rolled 5. That's 21 points. That's more than 20, so I'm done. Make sense? So it rolls until it gets 20 or more points. That means that your outcomes are, let's count, 20, 21, 22, 23, 24, and 25. 6 possible outcomes. How does that 25 come about? 19. You have 19 points and you roll 6. That's the only way you can really get 25 points in a turn as a computer. So our first exercise is to simulate a single turn of Pig where the player rolls until a 1 being a pig, is rolled, or the turn total is greater than or equal to 20. We'll call this strategy hold at 20. The user doesn't need to make any choices. The computer will just automatically roll automatically and use the following hold at 20 strategy. For each roll, print a line with roll and a random dice value 1 to 6. After a roll of 1 or hold, print the turn total. Okay, in the case of a pig, the turn total is 0, but we're not making any choices. So let's go ahead and do desktop pig.py. So, first thing we're going to need, import random. Def hold at 20 turn. Yeah, might as well make our names big, why not? Let's see. Yeah. 1 second. Tool configuration file. I'm just trying to figure out what's most visible from the back. Dark or light for the back people in the back? What? Dark? Yeah. Yes, no, dark? Or is it light easier? Oh, we'll go with this. We'll see how this works out. Okay, hold at 20. So now we've got a hold at 20 turn. Okay, we basically want to roll until we hit 20 points. So we're going to have a turn total. That is how many points we've made this turn. It starts at 0. And then we basically just need to roll, while turn total, there's a couple different ways to do this, is less than 20. Sorry. Let's see. Die is equal to, so while our turn total is less than 20, what are we going to do? We're going to do random.randint 1 to 6, right? Yep. Let's go ahead and just shorten that up. We're going to create a separate definition. Def roll. Even though it's very short, I'm just making it so I can say here. So we roll, our die is equal to what this roll, and then we basically have 2 outcomes. If die is equal to a 1. I'm going to put in pass just simply to say, hey, this is what we're going to do temporarily. I'll replace that in a sec. Else, if we didn't roll a 1, we'll say that's how many points. We say our turn total is equal to the die. Sorry. It's equal to turn total plus the die. Make sense? And then that's it for that one, because assuming everything goes well, we don't roll any 1s, we can just simply say return turn total. Of course, it wants us to print stuff out as we're doing it, but we will do that in just a second. Now, if it is a 1, our turn total is equal to a 0. And then we kind of have a couple different ways of doing this. We could break over here to break out of the while loop. Or just to emphasize this, we could do something like pig is equal to false. Pig is equal to true over here. So once we roll a 1, we get a tip. We roll a pig. And we would say, and we could do something like, wow, not pig, and turn total is less than 20, right? We could do that instead. Make sense? As opposed to breaking. Everybody following so far? So let's go ahead and add in some stuff. So let's add some print statements. Print roll colon and then comma the die, and then when we're done, print turn total comma, turn total. So if I run it, it doesn't do anything because I didn't call the function, of course. Run it. And we see roll 3, 6, 3, 6, 5, 23 points. So roll, boom, boom, boom. Let's do a few of them. So these all rolled a 1 on the second roll. Let's go ahead and see if that happens, if we can get a variation. Okay, so immediate 1, 3, 3, 1, 6, 1, 6, 1. Huh. It's a lot of turns where you don't get any points on this. So but then there I got it all. So of course the question is, I want to know is, how statistically viable is this, right? It's a question to have. So so let's go through this again. We created our roll function. We have a function called hold at 20 turn, which does a single turn for the computer. We set our turn total is equal to 0, because basically you'll have both a turn total and a score being the number of points you have, right? That's what gets adjusted at the end of turn. But then you have the number of points you've made this turn, the turn total. So that's what we're currently working on. As you roll the die, you'll add to that turn total. Pig is equal to false, meaning did I just roll a pig or not? While you have not rolled a pig and your turn total is less than 20, we roll the dice. We're going to print out that dice roll. If it's a 1, congrats, you just rolled a pig. Turn total is equal to 0. You lose all the points for the turn. Otherwise, if you didn't roll pig, add to the number of points you got. Once the while loop is over, print out how many points we made this turn. Make sense to everybody? Okay. So now let's go ahead and let's go ahead and that seems like our output. So let's look at hold at 20 outcomes. Simulate a given number of hold at 20 turns and report the estimated probabilities of the possible scoring outcomes. Okay? That's a lot of words, and I'm feeling very tired. What does that mean? Input, a single positive integer, number of turns to be simulated. Output, initially prompt the user with how many simulations. On the next line, print score and probability. So what's it going to look like? So if I ask for a million simulations, this is going to be the output, which is the score and the estimated probability of getting that as my turn total, right? So here it's saying I should be expecting that we don't get anything 62% of the time. And then 20, 21, 22, 23, 24, and 25, which are our other outcomes. So we could just simply, so let's go ahead and do this. So def hold at 20 outcomes. We're going to go ahead and take in a variable, which is the number of trials. That way, we can add in the whole input later, but because I always like to do that later. And then I will call this hold at 20 out, even though it doesn't do anything right now. Hold at. We'll do this over here. 1,000. Okay. So now let's see what we want to do. We have basically we need to run this a bunch of times. So for in range trials. So we're going to do this trials a number of times, 1,000, million, whatever. What are we going to do? We're specifically going to do roll, hold at 20 turn that many times. So we need to do a bunch of these turns and gather data from it. Now, we do have to make one adjustment, which is this. It's a lot of text that we don't want necessarily print out as part of our output. So we'll just comment out the individual turn rolls. Make sense? As we're doing this. Now, of course, now it runs and doesn't show anything because, there we go. Next, we have to actually gather data from this. That's where our return statement that I put in at the end, just kind of on reflex, will come into handy. This will tell me how many points did this simulated turn get. Did it get 0? Did it get 20, 21, 22? It's not going to have anything in between. Now, we do know all the values. We could just simply say, we could do something stupid like score 0 is equal to 0, score 20, have one variable for each of these, but that's dumb. We could also do a list, but honestly, what I find best in this case, since we know what there's going to be, since we know the numbers and I know what's coming up, and this is Monte Carlo, is that we're going to use a dictionary. Specifically, what is the dictionary going to have? I'm going to start it out at 0, 0. The key is a score, and the value is the number of times I've seen that score. Make sense? And what I'm going to do over here is I'm going to create a for loop for blank in range 20 to 27. Sorry, 20 to 26. My bad. No. Not blank, score. For score, and 7 years ago. For score in range 20. We're going to say scores of that score. Let's just go ahead and make that S so it's easier to read. For some S score, the number of times I've seen that is 0. So we'll basically be, what does this do? This basically initializes my range of 20 through 25 to be 0, right? We've got 20, 21, 22, 23, 24, 25. These are our possible outcomes, right? Rather than doing it like this. Why am I doing it? Sorry, rather than doing it like this, 20, 0, 21, 0. Rather than doing, I just decided to do it like this because I know what the future holds. Okay, so now that we found a score, we could do, basically we just say, okay, this is the turn total. Right, this is how many points you got this turn. And what we'll do is we'll say scores of that turn total is going to go up by 1. So we'll say the number of times we've seen that score goes up by 1. We'll go ahead and print out what we have so far. Print scores. And you'll see that we've seen 600. If we run this 1,000, if we do 1,000 turns, we see 636 zeros. 90 turns where we get 20 points. 86 where we get 21, and so on and so forth. Make sense so far? So we initialize, we do our turn, and then we print, and then we take that and we increment. Now there's a couple of questions you might be asking yourself, which is, okay, why didn't I just do it like this? And I'm going to do it like this, whatever this is, in just a second. And, so why don't I just do it like this? If scores turn total, if turn total in scores, else, why don't I do it like the way that you've seen me doing these counts before, right? And the answer is because of the way Python keeps things in order, which is that whatever keys go in first, that's the order in which it will keep track of things. So there were 595 turns where you had 0 points, 80 turns where you had 22 points, 94 where you had 21, So it's a bit harder for me to print out. Make sense? But because I know what my keys are in advance, what my outcomes are going to be in advance, I just simply say, I'm going to put those outcomes into the dictionary in order. Make sense? And basically say, hey, and that also obviates the need to even check if it's in the key, because if we know what our outcomes are going to be in advance, we can just simply do that. We can just simply increment it, don't even have to check. Let's do this. And now let's go ahead and get the output like how we wanted, which is it wants us to print out the score, estimated probability. So print score score /t estimated probability. Okay. And, whoops, was never closed. And so there, the /t, by the way, is a tab, right? We'll see how many of those I need. Okay. And then we just need to iterate through our scores. For S in scores, print S, and we'll do comma right here, and then we'll do scores S, which is the number of times I've seen that. And if I want them to have a tab in between them, let's go ahead and make them match. Sep nah, I'll just keep it like the way I had it. No, I'm just thinking to myself, I know this program. Score, estimated probability, SEP. I know the way Python works, so I'm going to do it the way that Python is better at. All right, so very close to what we need. Score, estimated probability, where we've printed out the key, which is that score, and the number of times we've seen that, but that's the number of times we've seen it, not the percentage. For the percentage, we need to divide by the total number of times. So scores divided by, but fortunately we're given that, which we don't even have to physically count it. It's trials. How many trials were there? And that is pretty close. Yeah, we have to add the bit where we actually ask the user to input this number, but you can do that bit. Right? That's not the interesting bit. So it looked like that only gave us like a 62% chance of victory. Sorry, of not victory, but like per each turn, only a 62% chance of earning any points if we held at 20. Can we do better? Hold an extra outcomes. As the previous example, but allow the user to specify what the hold value is. In other words, how many points do you want to aim for, should the computer aim to get, rather than 20? Right? Should it be 20? Should it be something else? What is the probability of reaching 100 in a single turn if you allow the CPU to hold at 100? So, this is part of the reason I did it the way I did this, because it will make it as easy to alter as possible. What I'm going to do is I'm going to copy and paste and then alter, because rather than rewriting what I did for a hold at 20 turn, I'm going to copy it and turn it into a hold at X turn. Makes sense? I'm going to turn this one into I'm going to go back to problem one, I'm going to turn it into a more generic version, so that I can specify, rather than going to 20, I want to go to some limit, right? So let's go ahead and do that. So here's, instead of hold at 20 turn, all I've done was copy this. I'm going to go and call it hold at X turn. And what we should definitely do is we should provide it with a, with some value, okay? So the user should specify, like we should, and we should call it something that's going to replace our 20, right? That's what this is replacing. We could call it stop, we could call it limit. I think I'm just going to call it limit because that, or we could call it hold, right? Yeah, let's call it hold. Hold at X turn, no, actually limit. Too many words otherwise. So too many things using the same word. So this will be our limit. While not pit and turn total is less than the limit, let's uncomment this out to just test this. Hold at X turn, and I will plug in, if I plug in nothing, I'm going to get an error because it says, hey, you specified that you have to give me a limit. You didn't give me a limit. Okay? And notice that this is the only change I made over here, this limit. So I could give it like 10, and there, notice that it rolled and we went all the way to 10. Basically, we only tried to get for 10 points. We still can get 0 points. Here we stopped as soon as we hit 11. So the one thing I do want to know, because I want to make sure that it still works in conjunction with everything, is what I could do very easily is that I'd like it if there was a way to do a default value. Basically, if I didn't put anything in here, Python provides a value. And you can do that. You may have seen this a lot in arguments and in documentation. Notice I just did an equal sign declaration right over here. So what this does is says, hey, if you don't provide a limit, that limit's going to be 20. Wow, that's a lot of, yep. So if you don't provide a limit for my hold at X turn, the limit's going to be 20 by default. Make sense? But, so see here, I'm not providing an argument, and it just simply did 20. On the other hand, if I do 5, right? Oh, you only need 5 points before we stop? Great, I'm happy with that, right? Happy to do that. So, and if I put in 20, well, it's like, well, yes, 20. You said 20, so I'll give you 20. Make sense? So that's just, that's again, that's one of the things I was alluding to, that I'll teach you new things, but not necessarily anything you need to know for the exams, right? So, hold at turn X. So now we actually need to collect data and see, so we can maybe do a comparison of some of success. So rather than a hold at 20 outcomes, let's go ahead and do what we could do is we could do something like this. Hold at X outcomes, trials, the number of trials we want to do, and limit. And once again, I'm going to make that limit equal to 20. So this actually, let me make the alterations for this, and then all I have to do to alter this now is say, hold at turn X. Well, I have to make some other alterations. But notice that we've got that if I run this now, hold it at X outcomes, we'll do 1,000, and I'm not going to give it any value, and it does this program, it gives me the probabilities, right? But if I don't give it the number of trials, it's going to error, saying one positional required argument. Oh, I don't have a default argument for it, so it doesn't know what it is. So you can have some values that have default arguments and some that don't, but they have to be but the way Python figures that out is what order are they coming in. So here, I'm going to say hold at x outcomes. We'll do 1,000. Once again, what I'll do is I will go and comment this out. And I will say hold at turn 10. Let's see what hold at turn 10 looks like. It looks like a big fat error. Why? Because it says key error 12. Why? Because this code over here says, hey, I'm going to set up the results so that your results are going to be 0 points, as well as 20, or you could get 20, 21, 22, 23, 24, 25. But if I'm holding at 10, those aren't the results I could get. If I'm holding at 10, the results I could get are 0, 0, 10, 11, 12, 13, 14, 15. So let's think about that for a second. So the minimum number of points I need to get and can get is the limit, right? That makes sense. Look over here, 20, 20. That makes sense. Replacing that with limit makes total sense. And then the highest value I can score in a turn is 5 more points than the limit, right? Where I get just under the limit and then roll a 6. So if my limit is, say, 12 points, right? If my limit is 12 points and I get 11 points, then the highest I can go out on this turn with before I stop, according to my strategy, is get that 11, roll a 6. Now I'm out with 17. So that's 5 more. So here we do limit plus 6 to go up to, but not include. Make sense? Up to, but not include. That value 5 more. So now, when I run this, let's see, what did I mess up? Key error 11. Oh, because I should say limit over here. I should say limit over here, not limmy. So there is 64 for hold at 20. And now let's try, I can do 10 instead. And if I hold at 10, we say we have a probability of 42% chance of throwing, basically throwing a pig. We can kind of check this out by going to the absolute minimum, which is 1 point. And we'll see that basically, of course, there's no chance you can get 1 because that would require you rolling a 1, right? So, and we'll take it as long as and we're going to stop as long as we score points. Let's go ahead and run this a couple of times so we can see the percentages a bit closer. So each of these outcomes, this is the outcome of rolling a 1, is 0.16-ish, or close to 16% chance, which is approximately 1 in 6, right? So the statistics do work out. Let's go and have some other fun the other way. Let's try to win. So if our hold value is at 100 points, meaning let's just try to win the game outright without, we stop only when we won the game entirely. 0 to 100, 1 turn. What are the chances of that? Well, it says 98.9% chance of that failing outright. Yep, 99% chance of that failing outright. Right, 99% chance of that not working. But a 1% chance of it working, which is actually pretty fun. Right? You have a 1 in 100 shot of just simply saying, nope, I'm just going to roll until I win. That's rather exciting. Right? So it's a game of basically figuring out, of choosing your strategy, sticking with it for a bit, and then basically having to adjust on the fly to see, okay, do I need to adjust this? Now, how would you go about figuring out what the best strategy was? Okay? What you would do is if you actually were serious about figuring out what the best strategy was, right? You'd have to simulate the entire game. And then what you would do is that we have this over here, this function for part 6 that you write called average pig turns, which figures out if you were just playing the game by yourself against nobody else, because that's really what you need for statistical analysis. How many turns does it take you to win? What's your expected number of turns to win? For instance, 20 holding at 20 expected values, 12.6 turns to win. But you could simulate this for basically every single hold value and see which of these gives you the minimum, which of these strategies gives you the minimum turn. So, and then you choose that. So, but we have to build up to there. So we have a hold at 20 turn, we have a hold at X turn, and then hold at X outcomes. So now, part 4. Hold at 20 or goal turn. Given a player's score, and this is actually one of those things that I have to correct a lot on final products or students. Given us a player's score, simulate a single turn a pig, where the player rolls until a 1 is rolled, or they've gotten 20 or more points, or the score plus the turn total is greater than or equal to 100. In other words, given the score, your current score as an input, and this hold at 20 strategy, roll until either you hit 20 points, or if your score is at like 90 or something, you've won the game, right? Because you have to actively have to decide to stop rolling, okay? If I start the turn with 98 points, as long as I don't roll a 1, I want to stop rolling as soon as I roll my dice, right? So that I can win the game. It doesn't make sense if I'm at 98 points. Oh, I rolled a 6. I'm going to roll again. No, I'm going to roll until I get 20 points. This is a common mistake I see where students basically, where the computer tries to win and the computer ends up with like 112 points on their last turn. And no, they could have won 12 points ago. They could have stopped rolling quite a bit ago. So this part's kind of essential. And we can adjust it. In fact, I am going to go ahead and genericize it for you. We're just going to use we're going to go ahead and use what I have here. I'm going to copy this. And what's great about doing this is I can alter this part. No, I'll create it as a separate function. I'll show you. Hold at X turn or goal. So given a limit, which is our holding value, but I'm also going to give ourselves our current score, which by default I'm going to say is equal to 0. Okay? By default, our score is equal to 0. Okay? And so what we're going to do, and otherwise we actually don't have to make much change whatsoever. Why? Because what we're going to do is say, while we've not rolled a pig, and the turn total is less than the given limit, and the turn total plus our score is less than 100. In other words, the amount of points we've earned this turn plus the current points we have is not enough to win, right? That makes sense to everybody? Right? The score is what we have banked up. Turn total is the number of points we've made this turn. As long as when these two things combine and get more than 100, I should stop because I've won. There's no need to go for more points. Make sense? And that's one of the other things you should, for humans, as I was saying, your humans should be stupid and be able to do that. But that's really all I have to add to this, right? For our output, we would then want to just simply print the roll, print the die, and then print one more bit of information. Return score is equal to turn total plus score. And this is important. I'm just going to return the turn total so you can adjust what score you're going to get, because you'll want to adjust whatever the score is outside of this function, right? So if we run this, give me a second. Okay, and I'll say, hey, yeah, our limit is we want to go until we hit 20 points, but I have 95 points currently. Right? So I have 95 points currently. Roll 2, roll 5, total of 7 points, end the game with 102. On the other hand, if I have 75 points, we're going to go ahead and run this. Roll 1, got no points for the turn, so my total score is 75. Here we go. Rolled a 5, a 3, a 3, a 5, a 5 for a total of 21 points. 21 points. 75 plus 21 is a grand total of 96 points. Make sense to everybody? So, here we go. Now, let's see. It's 3:07. So, since I have a bit of extra time, rather than doing these, I'm going to go through and give you pointers, okay, on how to do the rest. Hold at 20 or goal game. Here basically is just a solitaire game. Basically this is actually now where we're building a game rather than doing it one at a time. Here the computer will basically play according to this strategy that you give it, and it's going to keep rolling and adjusting its turn based off of its turn total. So you keep rolling and the game just keeps going until you hit 100 points, until the score is equal to 100 points. Part 6 is...
Why does it like just keep going over and over? Always this turn total if you score 0.
If it hits, are you getting 1? If it's 1s, you're going to keep getting, your turn total is going to be 0. I'd have to look at your code individually.
Is that right?
If you get a 1, it might be, depending on what you wrote. I mean, I'm going to share this on the code I have as an announcement. So, average turn. This is the Monte Carlo. The last Monte Carlo you have in this part of the homework. Average pig turns. What are the expected number of turns a solitaire game of pig would take? In other words, how long, if you're using the strategy, how long does it take you to win on average? Okay? And the way you would do this is you would adjust the part 5. You would adjust part 5 to count the number of turns it would take. A turn not being a roll of a die, not the number of dice roll, but the number of times you're calling this function, right? The number of times you're calling this function. So count that number of times and return it, and then you just simply do a running total, and then use that to create the average. Okay. Part 5. What we just did part 4, I'm describing how to do part 5, part 6, part 7, and part 8. Part 7, 2-player pig. Okay. Here, you're going to be simulating 2 humans playing this game against each other. Remember, humans are allowed to be stupid. Okay? In other words, they're allowed to, if they want to hold as soon as they scored a point, sure. If they want to go for, if they want to keep rolling, even though they already still have 200, even though they've scored 200 points this turn, they can keep doing that. You know, they're allowed to be stupid. Humans are allowed agency. Okay? So now if you notice, we've done the solitaire version, which is the computer playing by itself. We've done humans playing them by themselves. So part A is where you kind of combine that. You have one human player versus the computer player. Okay? So part 8 is basically playing against the computer. The first player is chosen randomly, and basically you alternate between who's rolling. So we'll see our actual game here. And so for demoing it or showing it to me, you'll be rolling. Basically, you'll be playing against the computer.
You guys can demo this?
Yeah, please, because otherwise it's a real pain to try to grade these things, because otherwise I can't tell you to go fix something, or it's harder for me to go tell you to go fix something.
So what should we demo it in our labs, or?
Demo it in your lab or to me. Either way works.